My name is Marcus Lynch. I'm the host for today. Together with me here I have David Lash, who is the presenter and will talk more about this topic in a short while. As said, this month's topic is, in this webinar we'll investigate further how Tekla software fits into the construction project workflow. We'll demonstrate how Tekla extend BIM value beyond design to virtual construction and project simulation. We shall show how our model-focused construction management tools validate and improve given information to better forecast positive project outcomes and help to deliver projects to plan. Isn't that true, David?
That's the case. That's right. Thanks very much, Marcus. And great that we've got a very wide spread of disciplines in the construction industry tonight in the audience. I'm very interested to know what you guys think of what you see and for your feedback. And of course, Tekla listens very carefully to what the industry says, and we're always looking at ways that we can help you with your workflow, help you to reduce risk, help you to increase your bottom line, get your profit going. So good to have you along. Now tonight we're covering three kind of fairly broad aspects of the industry, and we're broad in the fact that we're going pre-tender, talking about the bidding process. Then we're going to go into kind of a post-tender, kind of pre-contract, post-contract kind of situation, and then we're talking about work on site. So we're going to cover those three, but a specific part of those three, and hoping that you'll find something here that's relevant, particularly to workflow that you're familiar with, and that you can take something from tonight with you. So first up, let's look at a situation where the question comes through: if your part of the industry works in 2D. We've all been there, no doubt. Why should you be any different? And we're going to address that in a few moments. Second part, we're going to talk about what happens if your part of the industry now uses detailed 3D models. They're coming through from your different design consultants and the like. How can you integrate and manage the updates from the design team to establish the quantifiable impact of those changes? I'm sure we all really love revisions. We've had plenty of those over the years with your drawings coming through, and how do you manage the same kind of scenario when you're working with 3D models? Not quite as straightforward as checking off clouded revisions on a drawing, but Tekla provides the tools to work with that kind of workflow. And last thing, we're going to look at if your part of the industry now delivers incredibly reliable, detailed 3D models, how can you leverage virtual design data, the kind of stuff that you're looking out of from highly detailed software like Tekla Structures. How do you leverage that virtual design data from the model and to coordinate with the real conditions out on site, out there in the mud, amongst all the concrete, amongst the steel, and how do you ensure that to ensure instant as-built accuracy, reducing risk and rework. Okay, so the first part we're talking about 2D. So if your part of the industry works in 2D, why should you be any different? Now, many of those listening are probably only too acutely aware that the construction industry moves very slowly, and changes to the likes of construction contracts that we sign up to as contractors, they do have a huge impact on the way we do our business. So as a result, your design team may only offer the most rudimentary deliverables at a tender stage. Maybe like 2D drawings, PDF files, the written specifications, maybe a basic bill of quantities. This, of course, is a tried and tested industry standard, but what we're after is a way of getting one step ahead of the bidding competition. So at tender stage, with the ability to generate accurate quantities as well as to determine rudimentary scheduling information, time scheduling, as well as value engineering opportunities. And so that we can get ahead of the bidding competition, and of course which means more jobs. So on average, around 1 in 6 bids, I guess, in the construction industry project is met with success. So like you know, 1 in 6, that means you've got 5 bids that failed. That's a lot of abortive work. Some companies fare better, about 1 in 3. What's their secret? Well, that's an inside knowledge job, that one, and to know, but you can be sure that it's not just guesswork that's winning that kind of work. So let's take a look now and see how you can use Tekla to start to build a winning bid that will help you get out of the 1 in 6 club and get you across into the 1 in 3. Now, so we're looking at perhaps you've received the box. The box is full of drawings. It's got probably a CD in there with a whole bunch of PDF drawings on it, specification, bill of quantities, and all that kind of thing. So just taking the PDFs, for example, how can we use those to work with our bid, to get some decent quantities and understanding of the project? And in the case especially of when you've got complex structures. Now, if you've got a very basic design, if you're completely rectilinear, not so difficult to do with a ruler, and just fairly simple kind of quantity takeoff tools from paper. But when you've got things like curving elements, when you can't get true length lines from your drawings that easily, when you've got like a curving, say, wedge-shaped wall like you have here with a car park, which goes down to a cellar, that's a bit more of a challenge. Now, what we've got at Tekla, we've got tools to do that kind of thing. And some of these actually appear in something that by the name of extensions. Extensions are available to all maintenance customers for Tekla. And these are kind of ways that we feed back into a required workflow that comes through from a customer. So that's why it's really important to stay in touch with us. Let us know what your needs are. It's highly likely that your needs are also shared by others in the industry, and we can put together some quick code according to your specification to meet your need. And so this particular one here actually converts a PDF, which came through on your CD in the tender box, and it converts it to a reference object, which we can then take into Tekla structures. So for example, here's how it works: is that there's a PDF in front of you, and you're saying, "Great, convert it." And this is what it does. It comes in as something called a reference model, and you're going to refer it. You're going to bring it into your Tekla environment, and there it is, and it appears within your background. And that's not just a dumb JPEG. This is actually something you can click to, something that you can measure off. As you can see there, I'm just making a start with figuring out how this, with the quantities and the buildability of this curving ramp is going to be. As you can see, like modeling, basic modeling in Tekla, particularly for, in this case, you've got concrete, very simple, using simple tools like chamfering a slab, chamfering the outside, then we're going to go across the inside, chamfer the inside. But of course, this slab is rising. I've got about a 1 in 8 to 1 in 10 slope on that. So let's bring up the edge of that slab. As you can see, it's like twisting like a corkscrew now. Quite difficult to measure that with just a simple ruler of an A3 drawing. Much simpler to just model it. And so this procedure, as you can see then, we're now thinking about this retaining wall that runs around the edge of that slab. And once again, just using really basic tools that we've got here in Tekla to help you to model that. And this starts to give you some idea in the screen now of how that thing might be built. But hang on, let's see where we can go from here. So after a couple of hours, literally a couple of hours to get a head around how this would work, taken from 2D drawings, taken from your PDF, and there you go. You can start once you've got that model there, you can start working with it. You can start to measure it. So we're measuring volumes of concrete now, and also measuring formwork areas. Of course, the formwork areas are going to be different with this kind of roof structure and with your floor bearing, your ground bearing slab. But you're picking up numbers there, and those numbers that's accurate. There's 81 cubic meters of concrete and 660 square meters of formwork. And of course, the other incredibly handy thing, of course, is once you start modeling things in 3D, you begin to see things that aren't quite so obvious when you're looking at something like a 1 to 100 plan from your engineer on a drawing. And in this particular instance, it seems the engineer may have omitted hadn't realized, if you like, that the bearing capacity of the base of that ramp was going to interfere, or it's going to collide, if you like, with the pile caps on that structure next to it. And so that's the kind of information that you can get just from a couple of hours of modeling. It's kind of thing that's going to affect your bid, because you know that's going to come back as some kind of a RFI change order kind of scenario. Why not get in there early? Why not put it into your bid? And that way the confidence in your bid is much stronger, because you obviously know what you're doing. Of course, once you're modeled, you can start analyzing maybe the kind of things that also the engineer hadn't quite considered. You start looking at the way that these joints go together, the way that the ramp kind of meets those kind of connections you're going to have to the superstructure of the building. How about your waterproofing? How about things like your movement joints between this particular sloping and dropping drive, if you like, to the floor of the cellar? Other kind of things that I mean, you're going to be building it, so you might as well start looking at these things quite early and build your pricing around what you can see there in your scheduling. Better to come across these things early than later. Better to get them in your bid now, so that way you don't bid too low and find out later the reason why you're so low is because you forgot something or you missed something. Of course, another fantastic thing about when you're modeling with Tekla Structures is all the information. You can also take that and you can put it into the likes of a tool here called Task Manager, which is, it's more than just a time scheduling tool. It actually connects your model as you've modeled it to a time schedule. And so if you just follow this this animation for a bit here, it shows you how we're picking off these footings, and we're going to place them into this task. Now you watch how we place it in. You can see in here that the quantity has increased, and that quantity there is exactly the same amount that we're put into here with these strip footings, with these sloping and curving strip footings. Good luck measuring that with a ruler, by the way. And same on the other side. Watch it again. Watch the quantity as it increases. There you go, 22 cubic meters of concrete gone in there. Notice also on the Gantt chart to the right, that's increased. That's because you've got a planned production rate, and now you've got a planned start date, you've got a planned duration, and you've got a planned end date. And that's all based on the kind of figures that you're putting in the kind of historical data. That's the kind of thing that you guys would know how your company works, and better than I do. Of course, if you select a task within the Task Manager, it selects the elements it refers to. It's linked. It's linked. It's completely linked. And so you're not just typing in numbers of volumes of concrete given to you from an Excel sheet. You're actually taking directly from the model that you're going to be constructing from. Extremely clever. Very handy. There you go, all your cast work. All your formwork, of course, is taken from the exact same elements. The formwork's taking the vertical faces of those, and you can see there how these things are all updating automatically. You can, of course, change the production rate. Maybe your teams don't work quite that fast, dropping down 3 meters, and you see that the duration changes automatically as well. Extremely clever, very handy. Links. This information, of course, does link through to MS Project and to Primavera and to, what's the third one called? Asta, of course, in the UK. And the UK. And of course, you can isolate and just really get a real handle on the kind of things that the tasks which you're scheduling. You can visualize them. That's really useful, and we've had good feedback from that from our customers. Okay, and of course, once you've discovered, well, once your value engineering has your team has picked up on certain elements they'd like to maybe go back and discuss at some point, maybe post-tender, maybe pre-tender if that's the way your contract could be set up. You want to communicate that. Now, a great way to do that, of course, is with Tekla BIM-site. Tekla Structures connects directly to Tekla BIM-site. You can publish out. Select your model, send it out. Tekla BIM-site is free. It's a great tool for collaboration, as you're going to see in just a moment. We've just sent out the model that you've been working on, and what you're going to do now is you're going to send it through to your trusty 2D engineer, and you're going to say, well, welcome to the 3D world, and he's going to download Tekla BIM-site. He's going to open up this model, and he's going to come to grips with what he's been designing, perhaps realize the error of his ways, discovering, of course, that we may be lacking a bit of bearing capacity, and might be in need of a bit of a redesign of those footings. As you can see, the notes come through. We can add annotation to any of these parts, and he can pick those up automatically. And in the same way, he can add notes and send them back to you. And those little note files are tiny. They just email through, and they load straight into the location that he noted it. So I encourage you to head across the Tekla BIM-site website. Check out some of the webinars, and they really clarify the process of how you can use Tekla BIM-site for collaboration in a modern construction process. And there we see with the notes being made, And the ease of use, incredibly easy to use Tekla Insight, very simple, you don't need any instructions. I don't know if there are instructions anywhere if Microsoft for using it, it's so simple. There probably are.
There are videos that you can actually access through the plugins that use interface.
Okay, fine, there are. Okay, now so how to wrap that up? Let's wrap up. If you're part of the industry works in 2D, why should you be any different? Well, I think we've demonstrated there, you can win tenders by offering the best quality measured and value engineered bid based on your own 3D data rich model. It's a case of when you get complex structures in particular, you may want to model those out, and that'll give you exact quantities of volumes of concrete. It can give you a proportionate figure for your reinforcing, as well as for your formwork calculations and that kind of thing. The more data you put into model, the more time you put into it, the more data you can get out again, and the more valuable scheduling and value engineering information you can pull. Okay, that's the 2D wheel left behind. Let's move on to the 21st century now. So the question is that if you're part of the construction industry now uses detailed 3D models, how can you integrate and manage updates from the design team to establish the quantifiable impact of those changes? And that's a really great question because, of course, revisions are the bane of every contractor's life. How do you keep track of the sheer number of revisions that come through? And it wasn't particularly easy in the days of 2D, in the days of when you get the boxes come through from the printer and you need to update all the drawings on site. Not particularly easy these days with BIM models, but of course with Tekla we've got tools that were produced in response to your requests, and that's why you got to keep us posted with what you guys are doing and how you want to work, and we can work around that. So of course, for example, quick look here, show you how things have been done. The revision table, the dreaded revision table in the title block of the architect's drawing. We're going to run through an example, say revision E of this particular sample. We've got internal wall types and location changed. Thank you, Mr. Architect. Not very specific, but there you go. So you can go hunting now for the clouded parts of the drawing that show you that change. And then you need to determine where else to look for the information about that change. If you want to find all the needed variables in order to give a fair response to, say, this being a preliminary change order, these drawings are attached to it, that kind of thing, then you'll need areas, heights, lengths, volumes, specification of the wall, old one, new one, that kind of thing. With 2D, pretty much you want to do a lot of reading, a lot of hunting around, a lot of asking questions back on the phone, get out your scale ruler and start making some assumptions. But with the arrival of 3D information, more than that too, data-rich 3D information, now the playing field has shifted somewhat. Combined, of course, with the legal framework that gives you the access to that information as part of your contractual obligations, now you have a lot of extremely valuable information available to you. Information that can be directly used to find the accurate specifics of your preliminary change order. But the question we're asking here is, how do you measure that? I mean, really, how do you measure that and how do you manage those changes? So I'm going to take a quick step back just for a second, just for those of you who might not be familiar with what's possible within Tekla. And we're going to take a look here. For example, the architect, perhaps he is sending through his model. This is the same model he'll be using for doing, say, down to 1 to 50 scale drawing. So it's pretty accurate, very useful. Inside Tekla, you can break this model down into floors and phases and that kind of thing. And but also you can get complete analysis of the walls, the doors, the windows. And of course, this being his BIM model, this is exactly the same source of his door schedule, of his window schedule, of his room schedule, and that kind of information. And now all the information is now available to you. MEP, same story. At a design phase. Let's go back a bit. Sorry. Let's try that one now. And for MEP model, same goes for him. He'll be sending through his design model. It may not be the same as fabrication, but this is his design intent. And floor by floor, phase by phase, system by system, as much information as he places into the model is available to you as well. And just to put the whole thing together, of course, when you bring these all together, it's a great way of coordinating. Basically, what you've got is an as-built model pre-construction. And within here, all the information that your structural engineer used, I'm going to go up here, click on a beam. What do you got? Got a pass, and you've got the weight, you've got the material, you've got the profile. It's all there for you to look at, for you to analyze. Same with the MEP ducting. You're going to have radiuses, you're going to have your lengths, you're going to have the system names. It's all going to be available to you as a contractor. Again, architecture model down to 1 to 50. You've got all the information there about your heights, your walls, lengths, net side area, what's your painting area, what type of wall are you dealing with? You know, is it security class? Is it is it brick? How's it going together? Now, the thing though is it's one thing to get all this stuff in the same place, but the next thing is, so what happens when it changes? You know, how can you pick up on those changes? Because you know those changes will be coming thick and fast. But once again, head on over to the extensions. Again, extensions are available to all of those customers on maintenance. And within here you'll find one of the tools that is being produced is called IFC Change Management. Extremely clever tool, and it really hones in on this whole issue of change management of 3D BIM models from your consultants. And just going to run through now. Basically, what that means is for the case in point where we have, say, the change in the drywalling on the ground floor of this particular commercial premises, kind of a back of house drywalling. The architect needed to change specification from, say, just a rudimentary drywall system to a security standard, so that we're going to get pillaging between warehousing. Standard drywalling is quite cheap. Security grade, very expensive. You want to pick up on those changes and make sure that you can get your information for your preliminary change order bang on. So what you're going to do, architect sends through, has the previous version, revision C, sends through a new version for you to review and to base your change order information on. Revision E, really simple. They're both loaded into the model. And let's have a look at how the kind of things we're after. The name. The name is the type of system with the drywall and drywall security rated. And the net side area, because you want to know if there's changes to the sizes, if the architect has inadvertently or intentionally increased the amount of drywalling that is going to be forming part of this change order, this request. So that information you can pick it off. Any information that you could find in the architect's model, you can use it. All that stuff that you saw before, or that whole list of the net side area and that kind of thing, it's all available. And you can put it into here and compare it. So away you go, and choose those two, and head on up to the compare button. And you'll see this is really fast. This is the entire architect's model now being compared, one revision against the other. And you can see what comes through. Let's just drop it down and have a look at the area that we're kind of most interested in, which is in this back of house area, in this commercial premises. Now you can see here, it picks up things. It picks up the whole thing. What's deleted, what's new, what's modified, and this is all based on what you asked it, because you're asking for, has there been any change between the names or the net side area? And here you go. You've got one piece deleted, and it tells you what was deleted. And the area was deleted. What was the quantity of that? The intention here, and then is what's new, and the area of the new, and the rating of that wall, which is security standard drywalling. And of course, when you're coming into the modified, it shows you, it runs through, and it tells you what was the original type of drywalling, and what's the new kind, what's the old value, what's the new. And this is the kind of information that you want to get hold of. And you saw how fast that was. That was less than 5 minutes to set that all up. And what you're getting now is you're getting exact quantities, so you can send that through to your estimating department. Now, of course, you want to report on that. Of course you do. Print out a report of all the modified walls, save it out. It comes out as a text file. Any text file, of course, that reports out of Tekla can easily be taken into Excel, which is exactly what we're going to do in a moment. All the different parts that are modified are there. Send it out, and of course, and there you go. And there's your original. This is an original grade of drywalling. Here's the revised security standard, original area, and revised area. And that goes straight up to your estimating department. They'll be really happy. That was like less than an hour job, all wrapped up for you. You've got exact quantities there because you're taking it from the architect's model, and everyone's happy. So in terms of filling out in terms of building together some kind of response to preliminary change order, it's all there. You've got your when, you've got your where, what part of your building you're working in, you've got your what exactly, all of that's listed, how much, your estimate areas. The cost impact of that comes from your cost team. Impact on scheduling, in the same way as before, we were putting items into the schedule to determine the duration against a planned production rate and a quantity. You can do exactly the same thing. Put the drywalling in there, you've got a general rate of how fast you can build these things, and you can put off the quantity which is directly linked to the model. Okay, so that wraps that section up, and we'll be finished soon. I realize that we're probably running a bit over time, but I'm sorry about the late start. Okay, so if you're part of the industry now delivers incredibly reliably detailed models, now we're really getting into the real nuts and bolts, literally. Tekla structures, nuts and bolts, on-site, rebars, all that kind of stuff. How can you leverage virtual design data from the model to coordinate with real conditions on-site to ensure instant as-built accuracy, reducing risk and rework? Now, half the stories here, half the stories on the Trimble robotic total station side, and tools similar to that. But we don't have time to go into exactly how these things work today. Plenty of information there on the Trimble site, which you want to check out. But what I'm most interested here, of course, is what happens to that data. Now, these total stations, they kind of work with these files, and these files are very simple. Name, XYZ, comment. It's basically what you're after for general surveying needs. Now, that information goes across and it ends up in your computer. How you deal with that, that's where I'm most interested today, because, for example, here we have a 2D drawing. If you want to pick off 3D set-out points from there, you're going to have to be most likely tapping that in manually. But what happens if the 3D data is already there? This is the real value of having detailed, constructible 3D data and data-rich information in your model. And here's what we do. We can go back and forth, and then it becomes a very powerful tool. So, for example, DPR, for example, had a fantastic webinar back in June, and they demonstrate the clear benefits here with a number of on-site examples. And the particular site they were referring to was the Alta Bates Summit Medical Center in the States, finishing up next year. And of course, that webinar can be found on tekla.com. Now, just to run through some of the examples they covered. In this particular example here, this is demonstrating how not all existing structures are reported, of course, in site surveys and pre-construction. So we've got often things like simply turn up as the excavators go to work. So in this case, you've got a large existing foundation structure which was uncovered over here in blue in the photograph here. And so using the robotic total station, you can quickly pick up the field points of that structure, bring them back into Tekla, and then compare them with the engineer's proposed design and take a view of whether those foundations can be designed around the existing structure. So like you can see them over here. I mean, you've got interference here, but of course you don't need to wait to get onto site and then start sorting things out there. You can actually take the information back into Tekla, redesign your foundations, and then you can redo your bending schedules for your rebars and that kind of thing, and it's all done virtually. You don't need to get out there with your tape measure, with your bending machine, and then start figuring out how you're going to build that thing. It's all done virtually by taking the points off from your total station, bringing them back into Tekla. Similar situation was found also with the existing steel columns, as you can see in green here. These were once again these turned up during excavations. You just pick them off with your total station, bring them back into Tekla, and then you can sort of ascertain where the problems might be. And so this is your pile cap in here, pile cap and plan shown in here. You've got your surveyed columns, and here you can see the ones that are circled in red. There's a conflict there with your piles. Clearly those guys have to come out. Where you've got like a conflict with your pile cap, it's a different story. Those can be cut off below the pile cap. Where you've got a green, we're on here, that one there can be just simply left. We can work around that. And so that can all be done virtually. You don't need to get out on site and start measuring up things. You can just simply pick that off with your total station and make your decisions which ones are left, which ones are cut down, which ones are removed completely just from your Tekla model. This is a pretty good example too of the advantage of having a huge amount of detail in your model, and we're talking down to rebars. So here we can see more existing foundation structures uncovered, which are then surveyed with your total station, fed back into the detailed model, and the rebar is redesigned. I mean, the existing structures are shown here. Quite hard to see, but you get my point. It's in blue. You can see them a little bit in the photograph over here. And of course, those guys there were interfering with the proposed design, but all the rebar then can be bent back in the factory, because you do the redesign in Tekla Structures. You send out your bar bending list and that kind of thing direct from Tekla Structures to the machines at the fabricator. They fabricate off-site and bring them in pre-bend, pre-cut, that kind of thing. So saves you a lot of time. I mean, when you've got really heavy gauge rebar like you have here, you want to do that kind of stuff in a factory. And of course, with this kind of job, when you do it in that kind of a workflow, working straight off the model, you've only got a wastage of like about 1%. So yeah, fantastic cost savings, time savings. Once of course, once the piles have been driven, the ability to determine the accuracy of the position of those piles within a tolerance follows a similar but like hugely beneficial workflow, where using the total station, you can pick up the location of each pile, then compare that with the Tekla model to determine where the piles have gone out of tolerance. You can then redesign the pile caps, strip footings, the ground beams, all that kind of thing in the model. And then the redesign of the rebar, etc., is all done in the model. Again, send it for fabrication without the need to go through this process out on site. Huge time savings, and it's all done virtually. Keep your guys inside the hut until they receive the final load of rebar and get them outside. And of course, classic example, of course, of the total station is the things like anchor bolts and starter bars. On the left-hand side, you can see the DPR example. This guy's received 100% accuracy on the anchor bolts by using a template in the total station. The right-hand side, we've got a customer who uses the total station to confirm the location of the starter bars and the prefabricated elements. Of course, the factory doesn't send out these prefabricated elements to the confirmation the starter bars are in the right place. Really fast, really easy to do. Just set a total station, bring that file back into Tekla Structures, and all's confirmed. And that way you don't get any loads turning up that can't be fitted. And of course, when you're dealing with rebars and you've got like late changes, all that kind of thing is completely possible. In Tekla Structures, I mean, you can, because you do all of your redesign within Tekla, and then nothing's done out on site. So we've got a flange, extra flange added here, not a problem. Get it redesigned to Tekla Structure side, and the cutting and the bending is all done in the factory before it goes out to site. So many thanks to Nathan Wood of Tekla Construction for the webinar that he gave on this topic back in June. And I'm just going to wrap this up now. Three main things, remember, even though you're part of the construction contracting industry and it is a 2D wall-to-wall kind of place, you can be that difference with Tekla, and you can win work with less risk and less effort. Get out there, take those PDFs, get the model those complex elements, get in your best bid, and go in low with confidence. Integrates and manage the updates from the design team's data-rich 3D models. It can be done. We've got the tools to do it, and that way you can establish the quantifiable impacts of those changes that are coming through from the design team. And lastly, when you have data-rich models at your fingertips, you can leverage virtual Tekla design data from the model to coordinate with real conditions on site to ensure instant as-built accuracy, reduce